Now, coming to tonight's session, please allow me to welcome Sonali Burari, the moderator of this session. Sonali is currently working with Oracle as an automation QA consultant. She has 18 years of work experience, especially in the data integration domain. Sonali's passion is oriented towards shaping up the software products that will solve the day-to-day problems in the lives of the customers. She is a proud alumni of the Institute, pursuing the EMBA program in product leadership. Great to have you here with us, Sonali. Handing the session over to you now.
Thanks, Shama. And I'm absolutely honored to introduce Dr. Anish Agarwal in this forum. So before we deep dive into today's topic, let me give you a brief background about Dr. Anish. Dr. Anish is currently working with the NatWest Group as a director of data and analytics division. He's having over 20 years of experience with exceptional expertise of delivering value through innovative use of data across a spectrum of industry verticals. He is recognized as top 100 influential leaders in Asian analytics industry and is also one of the top 40 data scientists in India. He is an alumnus of Harvard Business School and is also a visiting guest faculty in a number of colleges and universities of India. Let me also walk you through some of his achievements. He has authored more than 15 articles on various subjects related to artificial intelligence and advanced data analytics. His well-known work includes interlock between artificial intelligence and quantum computing, application of artificial intelligence in wireless communications, and so on. He has delivered keynote sessions in more than 70 national and international conferences. He is also a member of AIM Leader Council, an invite-only forum of senior executives in data science and analytics industry. He has received numerous awards and recognition for his work in data analytics domain. He is also a member of the advisory board of colleges and universities, intending to set up structured courses for data science and artificial intelligence courses. He loves to spend time mentoring aspiring data scientists. So by now you must have all understood that Dr. Anish is the go-to person in the field of data analytics. With this brief background, I would like to now hand it over to Dr. Anish Agarwal. Thank you, Doctor.
Thank you very much for that warm introduction, Sonali. At times, it's quite embarrassing to hear so much about you and only to realize that how old one becomes after doing a lot in the career. But thanks once again. A very good evening to all the attendees, and I look forward for a fairly engaging and an exciting conversation over the next an hour or so. Well, today's topic, as you can see on the slide, we're trying to get the value of data in a digital world. What exactly is data analytics all about, the AI aspect as well. And before I actually start with my presentation, I want to share a quick insight. I'm not sure how many of you must be aware about Sir Alan Turing. Alan Turing is understood to be the father of artificial intelligence. And this instance relates back to the days when artificial intelligence wasn't as popular and perhaps what we know as Alan or the Turing algorithm right now. So this is for a point in time when Britain was at war with Germany during the World War II. And that is when the British army were looking for a mathematician or a statistician who could actually effectively decode the encrypted messages which were relayed by the Germans. What was in those encrypted messages were the exact positions of the ships of Britishers. So Germans were relaying that message. They knew the location of the ships and they were actually conducting a very pointed attack. And British army was in no way able to decrypt those messages because the system that Germans were using was a machine called the Enigma. And the beauty about that machine was that after every 24 hours, the Enigma changed its coding style. That means even if you were to crack the code or decrypt the message, the next day's message was actually encrypted with a different set of codes. And that's when Sir Alan Turing came into picture. And he said that, I can of course help the British Army. I can crack this machine. I can design my own version. And he designed his own version as as Christopher. Yes, you're absolutely right, Bharat. The Imitation Game is the movie that you can perhaps watch on OTT. The beauty about this instance is he was working in isolation secretly, and that's what actually made the local police and that's what actually put the local police in doubt. That what is he doing? He's actually working secretly. I hope he's not a spy. He's not a German spy who's actually spying on the local activities. And British police arrested him. And they started questioning him. And the very first question that the police officer asked him was, "We understand that you're making a machine which can think like humans. Is that right?" And Sir Alan Turing remained quiet. He didn't have an answer. The inspector said, "Let me repeat myself. I understand. I've learned from your neighbors, and it's a gossip in the city that you are making a machine which can think like humans. Is it right?" Well, that's when Alan Turing said, "Your question is partly wrong, partly right. Your question is right when you're asking, I'm making a machine. But your question is wrong when you're saying, I'm making a machine which can think like humans." And a very simple view is, two humans even do not think like each other. As an example, from a preference of likings about a fruit, I might like bananas, you might like apple. From a color preference, my favorite color could be red, your favorite color could be blue. So if two humans cannot think like each other, how can you expect a machine to think like humans? And that's when he said, let me correct. I'm making a machine which can think. And this is what actually forms the very base of artificial intelligence. A technique. So artificial intelligence is not a technology, it's a technique which is used, which is probably a sum of different algorithms, which actually provides an ability to a machine to think, to define a specific or to forecast a specific instance basis what the machine has been taught. And that's where the entire question or arguments or concept of training the models come into play. So with this, I'll start with my presentation. I thought I'll probably give you a quick of a review around what I've learned and what is more important from an AI standpoint as well. So if you can move to slide number 2. The value of data in a digital world. The upside of becoming a data-driven enterprise is tremendous. And the more data we collect, the more products and services improve, attracting more customers and deepens the relationship with those we already have. And that's what in turn improves future products and innovations and helps predict and shape future demands and pivots to a new business opportunity. And we've actually seen this in the recent times during COVID. When the entire world was at standstill, there were several innovations which actually cropped up just to ensure the customers' demands are met. So how are companies, doing in this area? After over 2 decades of collecting, storing, analyzing, and reconfiguring troves of information, are organizations really getting the value they expect from their investments in big data? And there is always a story around why it's big data, why it's not called data, why it's just not about small data. Big data it's about data which is in gigs and gigs of size, which gets generated every second. And the short answer, according to a research study on the issue, is no, not really every organization is able to harness the value of data. Many firms struggle to harness the power of data, and their challenges extend beyond just technology. So with this, what I've also done is to make this session more interactive. I've embedded a few questions around the quiz, just to ensure for those who are trying to doze off, the moment you are about to doze off, there's a question that will pop up on your screen, which perhaps it will be good for you to answer as well, and we'll make it as interesting as we can. So can we have the first question? So the question is, the term artificial intelligence was coined by whom? John McCarthy, John McDonnell, or John Adams? It's always interesting to see these bars, these animated bars moving on the Zoom window.
We'll give them a few more seconds, Dr. Anish. And meanwhile, audience, please feel free to post your comments and insights in the chat window. And if you're not able to take the poll, but I'm sure you must know the answer for this one, so post your answer in the chat window.
So if we have everyone who's answered, it's 100%. So yes, majority of people have answered right. It's John McCarthy. Great, thank you. Let's progress with the back. Can we have the second slide, please?
Yep.
So let's have a view from, pretty much a topmost view from 10,000 feet. And all too often, companies struggle to close the gap between the value that new technologies make possible and the value that their existing structures capture. An ever-expanding chasm I call trapped value. Basically, executives can see a bright future in which their business continues to lead, but just can't get to it. And often they can't even take the first step because of the nervousness around the change. And they find themselves trapped and thus vulnerable to disruption. And this problem requires not just a new strategy, but an entirely new approach to strategy, one that enables an organization, an enterprise to pivot wisely and keep several steps ahead of wave after wave of innovative technology that would continue to disrupt their businesses. And companies can now collect, store, analyze, and reconfigure massive amounts of new data, which amplifies the opportunity to and helps give them critical insights to deliver new business value. Perhaps, you would not believe 90% of the data in the world has been created in just 10 years, in the past 10 years. 175 zettabytes or 175 trillion gigabytes of data will be created by 2025, more than 10 times the amount in 2017. Next slide, please. And this is an interesting view, the data value gap. What you see on the slide is there's definitely a potential derived from value of data versus a current derived value, and there is a gap. Despite the availability of all this new data, so much of it remains underutilized, or maybe not all is used at all. According to a research by a research agency called Forrester, between 60% and 73% of all data within an enterprise goes unused for analytics. In their survey, only 32% of companies reported being able to realize tangible and measurable value from data, which only 27% said data and analytics projects produce insights and recommendations that are highly actionable. And this should be a cause of concern. If this figure was towards an upward of 100% or 50 or 80%, it would have still made sense. Well, if there is a gap between the current value derived from data and the potential value to be achieved from that data, companies can neither improve their core business nor lay the groundwork for growth in future businesses. And honestly, they won't be able to improve their operational efficiency as well, make more informed decisions, or create new products and innovations. In other words, they simply cannot pivot wisely. Can we move on to the next slide, please? So let's look at the first section, which is designing and delivering and how to really drive data-centric transformation of the business. Exploding quantities of data have the potential to fuel a new era of fact-based innovation in corporations, enterprises, backing up with new ideas and solid evidence. Powered by hopes of better satisfying customers, streamlining operations, and clarifying strategy. Organizations will have, for the past decade, amassed data, invested in technologies, and paid handsomely for analytical talent as well. And that's why data analytics or data science is understood to be the sexiest job of 21st century. Well, yet for many companies, a strong data-driven culture remains elusive, and data is rarely the universal basis for decision-making. Why is it so hard? Well, the biggest obstacle for creating database businesses aren't technical, it's cultural. It is simple enough to describe how to inject data into a decision process. And it is far harder to make this normal, even automatic for employees. A shift in the mindset that presents a daunting challenge. So, and that's why I've distilled 10 data commandments to help create and sustain our data culture to ensure data is at our core. The first one is, can we go to the next slide? Is data-driven culture should start at the very top. It flows from top to bottom. Companies with strong data-driven cultures tend to have top managers who are an exception, that decisions must be anchored in data. That this is normal, not novel or exceptional. They lead through example. As an example, at one of the retail banks, the C-suite leaders together sift through the evidence from controlled market trials to decide on product launches. At a leading fintech, senior executives spend almost 30 minutes at the start of meetings reading detailed summaries of proposals and their supporting facts so that they can take evidence-based actions. And these practices propagate downwards as employees who expect to be taken seriously have to communicate with senior leaders on their terms and in their own language. The example set up by few at the top can catalyze substantial shifts in company-wide norms as well. Next slide, please. It's really important for us to choose the metrics. Let's understand and let's agree that leaders can exert a powerful effort on behavior by artfully choosing what to measure and what metrics they expect employees to use. As an example, let's assume a company can profit by anticipating competitors' price moves. Well, that's been done almost by every enterprise right now. Well, there is a metric for that. Predictive accuracy through time. So a team should continuously make explicit predictions about the magnitude and direction of such moves. It should also track the quality of those predictions. They will steadily improve, and that's an assurity. And by creating a detailed metrics on customers' experience, the operator or an enterprise could make quantitative analysis of the consumer impact of network upgrades as well. To do this, the company just needs to have a much tighter grip on the provenance and the consumption of its data. That is typically in this case, and that's precisely what they should be looking at. Next slide, please. What's more important here is we shouldn't be pigeonholing our data scientists. We should just let our data scientists operate in a fairly independent and in an autonomous environment. Data scientists are often sequestered within a company with the result that they and business leaders know too little about each other. Analytics can survive or provide value if it operates separately from the rest of a business. And those who have addressed this challenge successfully have generally done so in two ways. The first tactic is to make any boundaries between the business and data scientists highly porous. Let them talk. As an example, one leading global insurer rotates staff out of centers of excellence and into line roles where they can scale up proof of concepts. And the second is then they may return to the center. A global commodities trading firm has designed new roles in the various functional areas and lines of business to augment the analytical sophistication. These roles have dotted line relationships to centers of excellence. Ultimately, the particulars matter less than the principle, which is to find ways to fuse domain knowledge and technical know-how. And this is where companies at the leading edge use another tactic. In addition to dragging data science closer to the business, they pull the business towards data science. It's a reverse methodology, chiefly by insisting that employees are code literate, and conceptually fluent in quantitative topics. Senior leaders don't need to be reborn as machine learning engineers, but leaders of data-centric organizations cannot remain ignorant of the language of data as well. So there's a thin line of difference between expecting someone to be data literate versus an expert coder. Data literacy is far more or holds greater importance versus expecting someone to be a strong coder. Can we move to the next slide, please? Let's also fix data access issues quickly. By and far, common complaint I hear is that people in different parts of a business struggle to obtain even the most basic data. Well, curiously, this situation persists despite a spate of efforts to democratize access to data within corporations. Starved of information, analysts don't do a great deal of analysis, and it's impossible for a data-driven culture to take root, let alone even flourish as well. Top firms use a simple strategy to break this logjam. Instead of grand but slow programs to reorganize all their data, they grant universal access to just a few measures at a time. For example, a leading global bank, which is trying to better anticipate loan refinancing needs, constructed a standard data layer for its marketing department, focusing on the most relevant measures. Next slide, please.
Yes, I'm moving it. 1 second. It's stuck.
And this is where technology beats humans. All right, quantifying uncertainty. Well, everyone accepts that absolute certainty is impossible. Anyone who says, I'm absolutely certain is lying. That's a myth. Yet most managers continue to ask their teams for answers without a corresponding measure of confidence. They're missing a trick here. Requiring teams to be explicit and quantitative about the levels of uncertainty has three powerful effects. The first, it forces decision makers to grapple directly with potential sources of uncertainty. The second, analysts gain a deeper understanding of their models when they have to rigorously evaluate uncertainty. As an example, one of the insurers based in the UK, they developed a core risk model and the model had failed to adequately adjust to market trends. So they built an early warning system to make these trends into account and spot cases that would otherwise have been missed. As a result, it avoided losses due to sudden spikes in claims as well. Next slide, please. And let's make our proof of concept simple and robust, not fancy and brittle. Normally, we target for a POC to be fairly big, chunky, tag millions of benefits around. But let's start with basics. In analytics, promising ideas greatly outnumber practical ones, and that's a fact. Often, it's not until firms try to put proof of concepts into production that the difference becomes clear. As an example, one large insurer held an internal hackathon and crowned its winner, an elegant improvement of an online process, only to scrap the idea because it seemed to require costly changes to underlying systems. Snuffing out good ideas in this way can be demoralizing for not just for organizations, but for colleagues and employees as well. A better approach is to engineer proof of concepts where a core part of the concept is its viability in production. One good way is to start to build something that is industrial grade, but trivially simple, and later ratchet up the level of sophistication. So start with basics, and of course, you can always scale up your use case. Next slide, please. Specialized training should be offered just in time. Well, this is a very important area. An organization may spend as much as it can on establishing the right tools, platforms, techniques, but unless you have the right human capital equipped with the right talent to deliver on the core job, the effectiveness of the overall DNA platform or strategy will be least. Many companies invest in big bang training efforts only for employees to rapidly forget that they've learned it if they haven't put it to use the right way. So while basic skills such as coding should be part of fundamental training, it is more effective to train staff in specialized analytical concepts and tooling just before these are needed. Say for a proof of concept, maybe. Try and acclimatize or customize the training as per the business needs. Next slide, please. Let's use analytics to help employees, not just our customers. And normally it's an outward focus for the enterprises where the use of analytics is only about improvising a service, enhancing customer satisfaction. But the organizations internally generate a lot of metrics about an employee as well. It's easy to forget the potential role of data fluency in making employees happier. But empowering employees to wrangle data themselves can do this, as it enables them to follow the advice in a memorably titled book on programming. Automate the boring stuff with Python. Wow. But the idea of learning new skills is to better handle data. Few employees will get excited enough to preserve and revamp their work. But if the immediate goals directly benefit them by saving time, helping avoid rework, or fetching frequently needed information, then a chore becomes a choice. Years ago, analytics team at a leading insurer taught itself the fundamentals of cloud computing, simply so they could experiment with new models on large data sets without waiting for the IT department to catch up with their needs. And that experience proved foundational when at last IT remade the firm's technical infrastructure. When the time came to sketch out the platform requirements for advanced analytics, the team could do more than describe an answer. And they could demonstrate a working solution as well. And that's what I will define as a future-ready team. Next slide, please. Let's be willing to trade flexibility for consistency. And many companies that demand on data harbor different tribes. Each may have its own preferred sources of information, bespoke metrics, and favorite programming languages. Across an organization, this can be a disaster. Companies can waste countless hours trying to reconcile subtly different versions of a metric that could be universal. Inconsistencies in how modelers do their work actually takes it all too as well. Companies should instead pick canonical metrics and programming languages. Next slide, please. Let's get into the habit of explaining analytical choices. For most analytical problems, there's rarely a single correct approach. Instead, data scientists must make choices with different trade-offs. So it's a good idea to ask teams how they approached a problem, what alternatives they considered, what they understood the trade-offs to be, and why they chose one approach over another. Doing this as a matter of course gives them a deeper understanding of the approaches and often prompts them to consider a wider set of alternatives or to rethink fundamental assumptions. Time for the next question. Can we have the question, please? Simple, yes or no. Is artificial intelligence a technology? You're close. I hope this was not an audience poll in KBC, else the contestant would be really confused. All right, so 52% say no, it's not a technology. 48% say it's a technology. Well, the answer is no. Artificial intelligence is not a technology. Artificial intelligence is a technique, is a framework, not a technology. Always bear that in mind. Okay, thank you very much. Let's progress with the next slide, please. Communicate. You know, it's really important to have the right strategy to motivate not just business leaders but also the stakeholders and other users of analytics, because it's important to communicate the right message basis the data that we have in hand. Next slide, please. And to communicate effectively, it is important that we define a clear data strategy. Obvious though this step may seem, only about 30% of the banks have a data strategy in place. Others have earmarked an ambitious program, as an example, to develop a new enterprise data warehouse, a data lake without an explicit data strategy, with predictably disappointing results. Any successful data transformation begins by setting a clear ambition for the value it expects to create. Reducing the time it takes to respond to a data request from a supervisor can generate cost savings in order of close to 30 to 40%, as an example. And organizations that simplify their data architecture, minimize data fragmentation, and decommission redundant systems can reduce their IT costs and investments by 20 to 30%. Banks that have captured benefits across risk, costs, and revenues have been able to boost their bottom line by 15 to 20%. However, the greatest value is unlocked when a bank uses its data transformation to transform the entire business model and become a data-driven digital bank. Next slide, please. Let's translate by identifying use cases that create value for business. And the key to get this is in the organization is to ensure everyone's aligned behind and committed to the transformation journey. This process typically comprises of 4 steps. In the first step, the institution breaks down its data strategy into the main goal it wants to achieve, but both as a whole and within individual functions and businesses. Next, it draws up a short list of use cases with the greatest potential for impact, ensures they are aligned with broader corporate strategy, and assesses the feasibility in terms of commercial risk, operational efficiency, and financial control. The third is the institution prioritizes the use cases, taking into account the scale of impact they could achieve, the maturity of any technical solution they rely on, the availability of the data that's needed, and the organization's inner capabilities as well. And the final step is to mobilize the data capabilities, an element including an element of the operating model and data architecture to deploy the use cases through agile sprints, facilitate scaling up, and deliver tangible value at each step. Next slide, please. Designing an innovative data architecture to support the use cases is very important. Many organizations radically remodel their data architecture to meet the needs of different functions and users, and enables the business to pursue data monetization opportunities as well. Many institutions are creating data lakes, large inexpensive repositories that keep data in its raw and granular state to enable fast and easy storage and access by multiple users with no need for a pre-processing or formatting. Choosing an appropriate approach to data ingestion is essential if institutions are to avoid creating a data swamp. Dumping raw data into data lakes without appropriate ownership or a clear view of business needs, and then having to undertake costly data cleansing processes. Next slide, please. We need to ensure that analytics insights improve the business means, actually by sharing the insights with key stakeholders who can enact on a recommendation. While sharing insights with influencers may seem helpful, sharing insights with the audience that can't enact recommendations will not directly ensure insights actually translate into business improvements. Being laser focused on speaking to the right audience can increase the pace of execution significantly, since working directly with decision makers speeds up the pace of making business decisions as well. And typically business decision makers are very busy with a lot of priorities competing for their attention, which is especially true in startups and fast-growing companies. Therefore, connecting the new insights and recommendations to the existing goals and objectives of the target audience is one of the easiest ways to grab and hold their attention. And a brief explanation of why the insight matters is very simple, because it's framed in terms of potential impact on the audience's key performance metrics, is a concise way of highlighting the value and the relevance it holds of an insight about the performance or the possible metric on success. Next slide, please. When communicating the data-driven insights, data visualization apparently is very helpful, since a picture is worth 1,000 words. However, data visualizations should not be seen as a replacement of written communications and insights. Today, tools like Power BI, Tableau have gained a lot of importance and significance for only one reason, because they offer us the ability to condense big chunks of data into visually appealing pictures and diagrams. Even though data visualizations take a leading role in explaining insights, they still require interpretation to be fully understood. And that's where there is a significant importance on which chart should be used for what purpose. When utilizing visualizations, avoid confusing the audience. Presenting unnecessarily complex visualizations can distract from the key insights and make the overall communication of an insight less effective. This often occurs because analysts have a bias towards using the data visualization technique that helped discover the insight, which might not be the best way to communicate the insight to every audience. Next slide, please. Analytics peer review can be effective tool for collecting feedback and ideas as one prepares for a broader communication. Peer review can go a long way in providing inputs on the story structure, while also helping validate numbers and statistics. Normally, in the race of meeting the timelines, we don't ever park time for a peer review. However, this is something that we should always embed. Get your presentation, get your project reviewed by a peer. I'm sure you'll definitely get some meaningful insights and inputs. Peer reviewing projects, sharing work, and brainstorming ideas always have been part of my team's culture, as an example. A review can be quick, as the reviewer has a lot of experience and can look at the metrics and add a lot of value. Next slide, please. Let's avoid extraneous trivia that distracts from the narrative. In an effort to appear data-driven, many presentations and documents include a laundry list of metrics presented without context, which have little informational value to the audience. Even summaries at times are sometimes inundated with numbers. Data presented without narrative can overwhelm even the most data-savvy audience. Extraneous data also presents a risk of audiences arriving at a different conclusion despite receiving the same information, despite receiving the most accurate information. This can result in meetings that devolve into confusion over data interpretation, and the biggest risk is the stakeholder losing interest in the overall value of data. Next slide, please. A structured communication strategy goes a long way in driving alignment with the audience. Consider a three-step comp strategy. The first step involves telling the audience the subject to talk, then actually telling them, and then summarizing what they were just told. This model gives the audience plenty of opportunities to understand the top-level topics and not get lost in the details they did not fully understand. In addition, using a framework to communicate the 5 Ws, which are very popular. The who, what, where, why, and when is often helpful in providing consistency to the communication and help output insights to a context. Next slide, please. And let's continue with the communication until the recommended action is complete. Data scientists oftentimes after sharing their insights move on to other projects. Well, let's not do that. This creates a disconnection between data scientists and the team executing on those insights, leading to delays or sometimes misinterpretations, driving suboptimal results as an example. As such, a proactive communication plan for the later stages of a project can minimize these risks as well. For example, for an analysis driving actionable insights, making sure the communication channels are open with regular follow-ups can help track the progress by providing a more efficient execution. All right, time for the next question. This seems to be an easy one. Artificial intelligence uses passive data or future data. Okay, we've got 75% responses. 92% of the respondents say it's passive data. Yes, you're absolutely right. Perhaps it's not just AI, but the entire concept of framework of analytics is based on passive data because you're working on data that's already been generated. You can actually generate insights which can forecast what will happen on a model, but the data that you actually play with is the passive data. Thank you very much. Let's move on to the next slide, please, which is perhaps an important aspect of measuring the efficacy of the data. And so significant enhancements in sensors and other measurement instrumentation, along with improved methods of networking and data storage, upstream and midstream providers have the capability to collect mountains of data. And in addition to relying heavily on human eyes to identify meaningful trends, using spreadsheets to glean actionable information from large volumes of data in a time is actually a very time-consuming and labor-intensive process. Using spreadsheets of data analysis makes it extremely difficult for analysts to make real-time decisions regarding how to manage their analysis. By aggregating, contextualizing, and visualizing information, big data analytics platforms give companies the power to quickly access the performance and health of their assets at the speed of thought of the engineers and analysts conducting the research. Next slide, please. Well, let's know the difference between your data and your metrics. And this is also important. How many views make a YouTube video a success? Let's say about 1.5 million, maybe. Well, that's how many views a video our organization, or an organization can post. It features some well-known YouTube celebrities who asked young people to donate their used sports equipment to youth in need, as an example. And it was twice as popular as in video, some other website had posted to date. Success? Then came the data report, and only 8 viewers had signed up to donate equipment, and 0 actually donated. Well, 0 donations, from 1.5 million views. So there's a charity firm which posts a video, 1.5 million views million viewers view it, but there's 0 return. And suddenly it was clear that there's something that didn't really, work well. So what happened? Well, you're actually looking at a wrong metric. A metric contains a single type of data. For example, video views, or it could be equipment donation. So what are we chasing here? A successful organization can only measure so many things well, and what it measures ties to its definition of success. For example, your definition of success could be X number of customers in X number of years, X number of sales over X period. It could be X number of new customers over repeat customers as an example. And let's take baseball. Every team has the same definition of success, winning the World Series, and on cricket as an example for India. Well, it's a touchy topic right now. This requires one main asset, which is good players. Unless we have good players, we will not win World Cup. But what makes a player good? In cricket, teams used to answer this question, they can answer a question with a handful of simple metrics like batting average, runs batted, and maybe, other metrics as well. And then came the statisticians. New metrics provided the teams with the ability to slice their data in new ways. Sports analytics today is a big industry in itself. It helps players to improve their performance by understanding the data in a different way and thus win more games, as an example. Organizations become their metrics. Metrics are what you measure, and what you measure is what you managed. Organizations can't control their data. We cannot. But what we can do is we can control what we care about. If a metric on the YouTube had been views, we would have called it a huge success. In fact, it could also be a massive failure as well, because the number of views may not translate to a tangible business outcome or a tangible revenue growth as well. Can we have the next slide, please? Well, it's known. Uber owns no fleet, not even a single cab. And Airbnb owns no real estate. Amazon doesn't produce any product. It's not into production. Yeah. Likewise, Flipkart. Well, these and other companies have grown very quickly with relatively little investment by establishing thin customer interface layers above complex systems of goods or services owned by third parties. They're just platforms. They're just intermediaries. Point is to keep thinking semantic layer for faster data and access reduced complexity of infrastructure, which harnesses next-gen connected data. And this is made possible through data minimization, a key concept in a digital transformation world. Data virtualization perhaps enables real-time access without replication. And as the name implies, data virtualization in a virtual approach to data management, it logically enables data consumers or applications to retrieve and manipulate data without needing to know the technical details about where and how the data is formatted and stored. Can we have the next question for the quiz, please? Okay, right, that's fine. Let's talk about.
Sorry, there wasn't a question. The next slide is.
No problem. That's fine. Let's progress with that, Shama.
Yeah.
Sustainance, ensuring strong data management and ethics. Well, more than ever, the ability to manage torrents of data is critical to a company's success. Cross-industry studies show, on an average, less than half of an organization's structured data is actively used in making decisions, and less than 1%, bear with me, less than 1% of its unstructured data is analyzed or used at all. More than 70% of employees have access to data that they should not be having access of. The intended use of data or unintended use of data conversation. And 80% of the analysts' time is spent simply discovering and preparing data. What's right for me? What's not right for me? What do I need? What I don't need? And data breaches are common. Rogue data sets propagate in silos, and companies' data technology often isn't up to the demands put on it. Having a CDO, which is Chief Data Officer, and a data management function is a start, but neither can be fully effective in absence of a coherent strategy for organizing, governing, analyzing, and deploying an organization's information assets. Next slide, please. That's when the quiz question comes. Simple question, deep learning and machine learning are two subsets of artificial intelligence or types of artificial intelligence? Okay, we will take 70% as a response rate. 83% of the respondents have said two subsets of artificial intelligence, and that's absolutely right. Both are subsets of AI, deep learning, and machine learning. Thank you. Let's move on to the next slide. And that's where it is important for us to set up a robust data governance to ensure data quality. And robust data governance is essential in improving data quality because many successful financial institutions have adopted a federal style framework in which data is grouped into 40 to 50 data domains, such as demographic data or pricing data. And the ownership of each domain is assigned to a business or a function that knows the data, possesses the levers to manage it, and is accountable for data quality, with metadata management such as mapping data lineage typically carried out by data stewards. It also monitors data quality, ensures regulatory compliance, supports data remediation, and provides services for the business in areas such as data reporting, access, and analytics. Next slide, please. Ownership. Well, the first principle of data ethics is that an individual has ownership over their personal information. That's just as it's considered stealing to take an item that doesn't belong to you. It's unlawful and unethical to collect someone's personal data without their consent. And some common ways to, in which you can obtain a consent is through signed written agreements, digital privacy policies, and ask users to agree on companies' terms and conditions, and pop-ups with checkboxes that permits websites to track users' online behavior with cookies. Next slide, please. Well, in addition to owning the personal information, data subjects have a right to know how you plan to collect, and data subjects in here is people, individuals whose data you're collecting. We all have the right to know how an enterprise plans to collect, store, and use our data. When gathering data, exercise needs to be transparent. Withholding or lying about companies' methods or intentions is deception, and both unlawful and unfair to the individual or the customers as well. Next slide, please. Privacy is an important aspect, and another ethical responsibility that comes with handling data is ensuring data subjects privacy. There's something called personally identified information, and PII is any information which is linked to an individual's identity. Some of the examples of PII may include full name, date of birth, address as an example, phone number, credit card information, bank account number, and passport number. I'd like to take a pause here and also explain that the onus of data privacy also rests on us as users as well. How many times do we think even once before inputting our complete name, date of birth, or even home address or mobile number in several apps which we download, which requires us to validate the address, us to validate a mobile number? And perhaps even if I was to ask you, how many of us have even read the privacy policy of Apple versus Google versus Facebook versus LinkedIn? I'm sure none of us have. If we as users are not aware or not conscious enough in terms of what data is being collected, well, we'll definitely be taken for a ride and our data will definitely be monetized. And for professionals who regularly handle and analyze sensitive data, mistakes can still be made. One way to prevent slip-ups is by de-identifying a data set. A data set is de-identified when all pieces of personally identified information is removed, leaving only anonymous data. Next slide, please. Well, intention is very important. When intention is good, as it said, for instance, collecting data to gain an understanding of someone's healthcare experiences, you can create an app to address a pressing need. But only if there's the right intention and a positive aspect around the reason why you're collecting data, and there's an absolute transparency as well. Next slide, please. Well, in data science principles, Harvard professor Latanya Sweeney provides an example of desperate impact. When Sweeney searched for her name online and advertising came up and read, Latanya Sweeney arrested. And she was not arrested. And this was strange. Well, if it's not clear from this example whether disparate impact was intentional or a result of unintentional bias in an algorithm, well, it's about the way data is aggregated. Either way, it has a potential to do real damage that disappropriately impacts a specific individual, a group, an enterprise, a company as well. Next slide, please. And here's how I would like to conclude. In the world of data science, one must excel in data creativity, skepticism, and communication. Interesting insights from data analysis will have to be shared with senior level decision makers and key stakeholders in a way that achieves maximum impact. The ability to effectively present and communicate findings by creating compelling stories to an audience that would very well be outside the realm of scientific data analytics is a determining characteristic of any successful data science. Companies today are increasingly under competitive pressure to not only acquire customers, but also understand their customer needs. And these services, which are probably customized, can certainly increase customer satisfaction. With this, I end my presentation. Thank you very much for listening to me. We can take questions now. Oh yeah, perhaps we can also have a last quiz question.
We have 2 more questions to go, actually. Can we take that?
Okay, I'm conscious we've got 5 more minutes. If we can, you want to skip it?
Sure, then we'll just jump to the Q&A part. Sonali, go ahead and ask the questions.
Okay.
Yeah, so the first question is from Mr. Lokesh Jain. What is your view on data-driven decision making for subjective decisions such as performance appraisals?
Well, that's an interesting question. Now, whenever there's an aspect of performance appraisals, and now let's dissect performance versus appraisals. When we talk about performance, it's about an individual. Appraisal could be if you may be appraising a vendor selection, or you may be appraising an individual as well. Well, let's accept the fact that performance appraisals are both quantitative and qualitative. While you can always set a benchmark when the metric that you're evaluating is quantitative, but when it's qualitative, there's several degree of subjectivity in terms of the way evaluation is done. And this is where, as if now, no enterprise has been able to fully automate the aspect of performance management. Because if a machine learning algorithm, let's say basis historic data on which it has been trained, evaluates my performance or even your performance, I can be so sure none of us will agree with the outcomes. Because what the history may have been, what the historical data may have been used to feed into that algorithm may be completely different to how our experience or how our performance may have been in the last 3 months, 6 months, or 9 months. And as an example, and we have seen this, the performance of each and every individual in the last 6 or rather 12 to 18 months has been at a different curve because people have been working from home. There were questions about, we will not let people work from home because there was always a good degree of distrust between employer and employee. Employers felt that people cannot work effectively from home. But look at it. In March 2020 or April 2020, world's biggest work from home experiment kicked off. And today it has emerged that work from home perhaps is a greater and a more successful model versus expecting someone to work from office. So 2 aspects, quantitative, yes, qualitative, owing to elements of subjectivity, we'll have to glean with caution. Back to you, Sonali.
Okay, thanks. So next question is from Selva Kumar. He mentions that he has extensive experience of around 33 years in dealing with data and business analytics in a conventional way. Data analytics and business analytics as on data recognizes only a formal qualification on the subject. Is it true, and what is the difference?
So indeed, there are 2 aspects of analytics. One is the business knowledge and second is the knowledge around the coding and technical. You've got vast and extensive experience. Even if it's not in line with the current tools and technologies, I would say it still fits pretty much within your ability to contextualize data set, to visualize your data set, to actually find a meaningful interpretation of the data set. I think the only thing that's required is an upskilling on the current tools, which perhaps will bring you at par with the current requirements of not just the industry, but of enterprises, and make you a far more successful individual.
The next question is from Gayatri. She mentioned that you have talked about Flipkart and Airbnb creating a thin layer with partners and data analysis. Can you please explain in details how this can be benefited?
Well, it's fairly simple. So Airbnb, or even let's extend Airbnb, Make My Trip, Flipkart, Amazon, Uber. Well, none of these carriers, or even Ola, for example, they do not actually provide the service themselves. So Uber doesn't own a single cab, neither does Ola. Amazon doesn't produce a single product, neither does Flipkart. Make My Trip doesn't even own a single property, and likewise Airbnb. All these digital firms are actually acting as an intermediary between customer and the service. They're offering a platform, and all they're doing is bridging the gap. So what does Uber does? Uber actually plays with 3 data points. The first data point is of me as a customer, my pickup location. The second data point is of a driver's location, where the driver is currently at. And the third data point is of the target destination where I want to go. It matches these 3 data points, and the algorithm defines what is the most pragmatic and feasible solution for me and recommends the nearest cab. So essentially, they are just the intermediaries or the platforms which are offered to the customers. And that's what Amazon does. You want to buy a product or a service, Amazon will recommend it to you based on your search history. Amazon will throw offers to you because you may have purchases you like to recommend. That's about it. Okay, I'm conscious of time. If there are any more questions, I'm happy to take offline. I have a hard stop now. But before
I'm completely okay with that, Dr. Anish. Yes, please go ahead. You were saying something.
No, all I want to say is thank you very much for inviting me. And I look forward to have similar conversations in the future with the group as well.
Thank you. Thank you to you. It's been an honor having you here as a speaker. And thank you for the brilliant and engaging session, Dr. Anish. And it's been a complete pleasure having you here. So please accept this certificate of appreciation from the Institute, a small gesture.
Thank you.
And we'll share the recording to you by tomorrow, sir. Thank you for being here once again.
Thank you very much, Amma. Thanks, Sonali. Thank you, everyone. Have a good evening. Bye-bye.
Thank you, Sonali, for facilitating this session seamlessly. And look forward to having you for the future sessions as well. Audience, if you found today's keynote useful, please share your thoughts and feedback by scanning the QR code on the screen. Let us know your feedback so we can improvise on the future editions of the festival.